right, going back to binomial theorem. I'm expanding this binomial using the binomial theorem instead of Pascal's triangle. First, I'm just doing the variables. If you were watching the last part, I think I had a b to the fifth here, so I've changed that to the end of the fifth, which is what it should be. Okay? Now, look at how I do the coefficients. We know that the first one is always a 1, right? Okay. Look what the second coefficient is going to be. 5 over 1. I just want you to look for the patterns. This third coefficient is going to be 5 times 4 over 2 times 1. Looks complicated, but it's not. Look for the next one. 5 times 4 times 3 over 3 times 2 times 1. Look for the next one. 5 times 4 times 3 times 2 over 4 times 3 times 2 times 1. Next one. 5 times 4 times 3 times 2 times 1 over 5 times 4 times 3 times 2 times 1. All right, we got to simplify these, right? The 1, we don't even have to put a coefficient there. This is obviously just 5. I'll put a 1 here just so you can see it really clearly, though. What happens here? Well, the 2 and the 4 are going to cancel. 5 times 2, 10. How about this coefficient? The 3's cancel. The 2 and the 4 cancels. Now I have 5 times 2 is 10. What happens here? 4's cancel, 3's cancel, 2's cancel. I end up with 5. What happens here? They all cancel. I have 1. Can you see that these coefficients are exactly like the sixth line of the Pascal's triangle? All right. I'm going to skip that one for now. Let's do this one, which is what we did in class. Okay? This is as hard as it gets, really. So first thing I'm going to do, I'm going to go ahead and write all of my variables out. So I'm going to have 3x to the 4th. 3x cubed times negative y. 3x squared times negative y squared. 3x times to the first power times negative y cubed. And then I have 3x to the 0 power times negative y to the 4th. Okay. Let's put the coefficients in. This one's going to be 1. This one's going to be 4 over 1. How did you know it was 4? It's because we're taking it to the 4th power. How about here? I put a plus sign. This is going to be 4 times 3 over 2 times 1. How about here? 4 times 3 times 2 over 3 times 2 times 1. Let's do 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1. All right, we have got to simplify. If I simplify this term, what do I get? Remember, we have to take the 4th root of 3. That's 81x to the 4th. Plus, okay, how do you simplify this? First of all, what are we going to do with the negative sign? Let's put the negative first. So we'll change this to negative. Okay. Let's simplify this. 3 to the 3rd power is 27. You might get a calculator out. 27 times 4, I think that's 108. So first you do the powers, then you multiply by the coefficient. So 108 x cubed. We've already taken care of the negative sign, so I put a y. Plus let's simplify here. Let's take care of the sign. It's going to be positive, right? I'm going to leave that plus sign. Let's do the coefficient. I'm going to do 3 squared, that's 9, times, I can simplify this. 2 times 3 is 6. So 6 times 3 squared, or 6 times 9 is 54 x squared y squared. Let's try this one. What's the sign going to be? I've got negative y cubed, so the sign's going to be negative. Okay? We'll simplify here. The 3's and the 2's cancel out. I end up with just 4. So 4 times 3 is 12 x y cubed. Okay. What's the sign going to be for this last one? I have negative y to the 4th, so it's going to be positive. This whole thing cancels out. I'm going to have a 1 here. Y to the 4th. Notice the pattern of the signs. Positive, negative, positive, negative, positive. Okay. Is this a series? Yes. Is it an arithmetic series? No. Is it a geometric series? No. Is it a recursive series? Well, a little bit, right? Certainly the power of the x depends on what the power of the x to the previous term was. It's a new kind of series for you. All right, closure. If a couple has 5 children, what is the probability that they will all be boys? Okay, let's think of it this way. Actually, instead of using the binomial theorem, you could just use Pascal's triangle. If you are taking something to the 5th power, b plus g to the 5th power, you use the 6th line of Pascal's triangle, which is 1, 5, 10, 10, 5, 1. That means that there is one way to get 5 boys. Boy, 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 boy. There are 5 ways to get 4 boys and 1 girl. Okay? There are 10 ways to get 3 boys and 2 girls. These are all the possible ways that the children could end up. Altogether, that's 32. And there's only one way to get all 5 boys. So the probability is 1 out of 32. Hope that helps.